listening to Emma equals MC squared, a podcast where I can help you learn or review about science in a fun and fast way too. Please leave a comment or review in the comment section below so I can help others learn about science in a good way. I'd like to keep these as ad-free as possible, so please support me by checking out my store link in bio, where I sell lots of fun posters and products, and some of them do, in fact, relate to the podcast. Now, to the episode. Welcome, and today we'll be talking about measurements. Measurements are pretty important things in science, obviously, because you need to know the measurements to do experiments and to figure out a bunch of other stuff. In science, we will use the metric system. Only the metric system. This means centimeters, milliliters, kilograms, and grams, and all of that. You will have to convert from kilograms to milligrams, so here's a trick that one of my middle school teachers taught me. King Henry died by drinking chocolate milk. King is kilo, Henry is hito, died is deca, by is the base, which is liters, grams, or meters, drink is deci, chocolate is centi, and milk is milli. You can also draw a staircase while saying this, where each step is one of the measurements, or one of the words. If you go up, you will be dividing by 10, and if you go down, you'll be multiplying by 10 for the staircase and for this saying. Now for converting from Celsius to Kelvin. This is a pretty simple one that oftentimes teachers will give you it, but I'll just tell you it. It's 273 plus the degrees Celsius to get to Kelvin. Congratulations, you have now upgraded to scientific notation and sig figs, something that a lot of people seem to dislike. Not entirely sure. I think they're fine, but, here we go. Scientific notation has to be with any number less than 10 and greater than 1. And you write it, whatever the number is, times 10 to the power of whatever. The power of whatever is what number you need to move the decimal back to the original number. Take 2,400 for example. In order to get this into scientific notation, we need to move the decimal to the left 3 times, because 24 is greater than 10, so it has to be 2.4. Because of this, the scientific notation will look like 2.4 times 10 to the third, because we moved it 3 times to the left. Now let's say we have a number like 0.0035. It's already a decimal, but it is less than 1, so we have to get it greater than 1 and less than 10, so it should be 3.5. With this, we have to move the decimal to the right 3 spaces to get 3.5. So this scientific notation will look like 3.5 times 10 to the negative third, because we will have to move it and make it a number less than 1. We have the negative sign. Now for sig figs, or significant figures. In my opinion, multiplication and division is the easiest one to do, or at least the easiest one to remember because you do it the most. You take the number with the least amount of digits, for example 2 and 14, and since 14 has 2 digits and 2 only has 1, so that means your answer will have 1 digit because that is the number with less digits, if that makes sense. I'll do another example. Say we have 25 and 135. 25 has 2 digits and 135 has 3 digits. The one with the less amount of digits is 25, which only has 2, which means your answer will only have 2 digits in it. Now for zeros. It's important to know. If you have 1 and 10, then they each have 1 sig fig, because you only start counting once you reach a number that is not 0. So if it's 1 and, say, 0.01, it's still only 1 sig fig because it's the only one there after the zeros. But if there's a decimal, it's very important that you pay attention to the zeros, because the decimal is telling you that the 0 is important. So say we have 80 with a decimal, then that 0 is important, so it'll have 2 sig figs. So if it has a decimal, then the 0 is important if it's after it. In the sense of 0.01, it's not important. I know, kind of confusing. But the decimal is only important if it's a number greater than 1. If it's a number less than 1, then the decimal is not important, and you go until you reach the first number that is not 0. For addition and subtraction, you go to the last spot where both the numbers have a number in it. So say we have 1.5 and 1.45. They both have a number in the tenths place, but only one has one in the hundredths place. Because of this, you will only go to the tenths place in your answer. I know that's a lot. It'll get better as you practice more, I promise. Now for conversions. Say we have 125 milliliters of juice, and 100 milliliters of juice is equal to 13 milliliters of water. And say we want to convert that juice into milliliters of water. So what we do is 125 milliliters over 1, because it's a whole number, and every whole number is over 1, and multiply it by 13 milliliters of water over 100 milliliters of juice, so that the milliliters of juice cancel out. The units do, not the numbers. So that way you're just left with 13 milliliters of water times 125. And that is divided by 100 as well. Now let's apply the sig figs to it. 125 has sig figs, but because 13 and 100 are a direct ratio, remember 13 milliliters of water in this made up scenario is equal to 100 milliliters of juice, and they have an infinite number of sig figs because it's a direct ratio. So we have 3 sig figs with the 125 milliliters, so your answer will have 3 digits in it. I know that was a lot of information. Feel free to go back and listen to it, or comment questions down below and I'll try my best to answer them and explain in the best possible way. But thank you for listening, and I'll see you later. Thank you so much for listening. I really hope this helped, and thank you so much. I really appreciate you listening to this. Be sure to leave a comment below and let me know how I can improve, and to check out my store. Until next time, Emma equals MC squared, out.